Hello, everyone. Welcome to Unfair Fights. I'm Rebekah. This is my brother Nathan, and tonight we're talking about are petrified trees a problem for young Earth creation? Nathan believes in evolution in an old universe, and I think evolution is false, and I'm a young Earth creationist. We take turns challenging each other, and tonight Nathan's challenging me. Do you want to talk more about the challenge, Nathan?
Well, just that if there's any unfair friends to help Rebekah tonight, she might need it. But yeah, other than that, I think, if you are an expert or if you have information or you want to comment, please do. And we'll try and look at the feed, or Rebekah will, I guess, as time goes on and post some comments, and you can help us out.
Yeah.
So, without further ado, tonight we're going to be talking about petrified wood, and specifically a place called Specimen Ridge in the I think it's Lamar Valley uh, in Yellowstone. And what I'd like to do is kind of go through things that I think we're both in a little bit of an agreement on, just so people get an understanding of how petrified wood occurs. And Rebekah can challenge me on that if she has a different way of doing that. And then I'd like her just to explain her worldview. And then I'll try and poke some holes in that. So petrified wood, what is it? You come upon a piece of something that might look like wood, but then it's made out of rock. What's going on here? Well, wood is organic matter, but if it falls down or is in place and suddenly isn't exposed to oxygen, then minerals can begin to replace over time the organic material. So it starts. There are basically two bits of it, and silica begins to replace it. Part of it is cellulose, and then there's also something called lignin. And under different circumstances, you can get this type of replacement happening rapidly or more slowly. And you can also get more details with certain processes. But essentially, the wood becomes a piece of stone. And one thing I think we would agree on is that it requires that oxygen be removed, and that could be by, being buried in volcanic material or underwater. And, you need to have a highly mineralized substance that's then going to start replacing that wood. Do you disagree with any of that, Rebekah, in terms of?
No.
Okay, so maybe we can show a picture, the slide here of a piece of. So you can see that different materials might make slightly different colors. This is kind of different minerals that might be a part of it. You can see tree rings on some of them. And so I think we're in agreement with that. So we're just going to move on to the next one. So what I'd like Rebekah to do. Oh, yes. All right. So I wanted to throw her kind of a softball tonight. And what I'm showing here is that if you search for the age of Specimen Ridge, you'll see that on the first page of Google, you already have a creationist website showing up, poking holes and fun at evolution and giving a separate so this is kind of a warning to scientists. Come on, people, wake up. Make some intelligible information for people to read, or this is what's coming. So I think tonight Rebekah has really no leg to stand on in terms of saying there's nobody researching or that kind of thing. Now, she should have already read this, maybe. I don't know. She didn't have any chance to research. So maybe some of you unfair friends could look at that. So Specimen Ridge, age of Specimen Ridge. All right. So Rebekah, go ahead and go on to the next slide. Here's an ancient picture from I think it's 27 on the left. Okay, and it has some petrified. I think they're kind of like these, kind of like redwoods. sequoia. They're giant trees at the top of one of the ridge, and on the right hand side, we see a face of this ridge, and it has a ton of different components to it. I mean, if you read the small text there, we have I can't even read it on this screen here, but you can read that little caption. It's got tons of different layers, lahars, and different things. Kind of a real mashup of materials and different stratum, and it does look like something horrible has happened, like a giant flood. So, Rebekah, take it away. How does a young Earth creationist explain these petrified trees? Some of them are laying down, some of them are standing upright, and all of these different layers. What's happened here according to the young Earth model?
Well, I do want to ask before I say that, because what I say will depend on something about this. And just so people watching know, the deal with unfair fights is I'm not allowed to research the topic that Nathan challenges me with. So I haven't been able to look up this specific place and find out about it. So I want to ask, what kind of sediment is that? Like, are there layers of volcanic ash? Like, what's going on with these sediment layers?
Yeah, so this is the northeast side of Specimen Ridge, and a lot of my information comes from a report that was done in the 1960s and 70s by scientists. This particular area of Yellowstone has been scrutinized scientifically for 130 years. And this particular figure, this particular part of the area says well-bedded alluvial facies, volcanic breccias, conglomerates, sandstones, and airfall tuff of the Lamar River Formation in the fossil forest along the northeast side of Specimen Ridge. And so when you look at what the definitions of some of these things are, volcanic breccias are basically it's like sharp volcanic material that's not well connected to itself. So it's kind of like if you imagine a bunch of lava rocks being glued together. Okay, I think that's kind of, but maybe smaller than lava rocks, right? Conglomerates, these are also kind of like, things that are stuck together, but maybe better rounded things. Sandstones, that's sand that's glued together. Airfall tuff is what happens when particulates in the air settle down and over time get glued together. So it's basically a bunch of different, volcanic and other sedimentary material that has been glued together by water, probably.
Okay, that's perfect. And then what is the evolutionary explanation for this area?
Well, I'll get to that. I want to hear I want to
Okay.
hear what
All right.
the young Earth people have to say. I
Okay.
mean, you got a
Well,
bit
good.
of something else, right?
Actually, I actually think I might have a good explanation for this, because Mount St. Helens erupted, back 40 years ago and so when that happened, all this stuff in Spirit Lake was all these sediments were deposited, and there were a bunch of trees that were like floating in the lake. And so they were all floating on top of the lake for a while, like I don't even know, but maybe even a few years. And then after they had been there a while, they like turned upright and went to the bottom of the lake. And so it actually appeared that they were like forming in the same way that we see these trees standing upright. And then, so what this looks like to me is that sediments like that same type of thing happened here. And you mentioned that there's volcanic material. So this may have been close to a volcano, and then also near a body of water. There may have been this opportunity for these uh, trees to have been disrupted by the volcano, and then they eventually formed upright and sediments deposited. And then the process that you're talking about, where minerals come in, and because they're buried in sediment, they're not in the presence of oxygen, and so this then the mineralization starts. And then I'm not sure why these are sitting up on the rock. There may have been some erosion that happened around those, and so I'm guessing at the top of the hill there's quite a lot of wind and things that may have eroded that sediment. So that's my explanation.
Well, so far you are doing fantastic as a old Earth creationist or old Earth evolutionist, because you're right. That is essentially what scientists believe about that. So I'm a little confused. So where are we in conflict? When do you think this happened? Did it happen 50 million years ago, or when did it happen?
Well,
What's your
of course,
timeline?
as a
How
young
long
earth
do you have?
creation sorry, as of course, as a young earth creationist, I don't believe that we've been around for millions of years for this to happen. So I
Okay.
would say somewhere after the flood. So
Oh, after the
with
flood. Okay.
within the last 5,000 years.
Okay, so within the last 5,000 years, you believe that this happened according to what the scientists say happened.
I just want to point out, whenever you say the scientists, you're assuming that all scientists accept the evolutionary timeline and the long timeline. But there are lots of young earth creation scientists who are very well educated. And so right now you're
Okay.
talking about the old earth believing scientists.
Well, what I guess what I'm saying is that except for the time scale, you are in agreement with what uh, scientists are saying about this. That it's water based, right? Things were deposited there, and that it was after volcanic action.
Yes, sounds like exactly the same thing that happened with Mount St. Helens, right? So I would say, yeah.
Okay. Wow. Well, this is interesting, because I was expecting a flood narrative to do this. So I guess we might have a problem, because you've blown up all my arguments by agreeing with scientists that this happened through volcanic action and water after that, or some sort of lahar or whatever from a volcano. Okay, so I'm going to have to recalibrate here, and so you think that this buildup, there's like I think at certain places there's 137 layers, uh, so that this buildup, it occurred in the last 5,000 years.
Yes.
And you said yes. I think you cut out there for a second. You said yes.
Yes, I said yes.
Okay. All right. Well, let's go a little bit further then, and go ahead and go to the next slide. So, one of the things that I noticed when I was looking at young Earth creationism is that there was this emphasis on some of these fossils that would transcend the layers. So I just wanted to have a couple of pictures here that I think are very interesting. The one on the left is a fossilized tree, and it is grounded in one layer, which the author calls the organic layer, and then there's a volcanic layer on top. Okay, so it transcends two layers of time, because the fossil has endured or whatever long enough to be buried by another layer of volcanic action. And the one on the right is very interesting. because it is a fossilized tree that has survived the erosion of the land around it. And that erosion has also cut into the layers below it. And it has kind of slid down into this crevasse, right? So the action around it is kind of like on a beach. You put your hand there, and the sand kind of cuts around your fingers and might cut these grooves. And so here you have this tree that's kind of being, it's almost kind of like acting as a wedge, going deeper into the layers over time. And you could imagine that in the future, another volcanic action or something would bury the top end of it, and then it would look like it had transcended time by millions of years. What do you think about that, Rebekah?
Well, what's your specific question about it? Because I mean, for me, there's not the millions of years. So I have no problem with the way that's sitting there right now. But is there a
Okay.
specific challenge to young Earth related to that?
Well, that's usually one of the things that young Earth people are pointing out about how stupid the millions of years in the time scale is, right? That you have these things that seem to transcend the barriers.
Yes. But this one actually doesn't really look like the ones that they complain about, because this one it doesn't really seem to be like it's sort of like on top of everything. I mean, it's going through, but it more looks like it got jabbed in. So I'm not an expert in this, obviously, but I wouldn't take this picture and say this is a problem for evolution. But there are polystrate fossils that are a problem for evolution because they are situated in the middle of the rock layers, and they're totally, down in there, and they are like buried across supposedly millions of years of sediments. So I think that's a problem because you can't even figure out. I mean, this one looks like it just got stuck down in there. So, I mean, to me, it's this. I'm not going to complain about this with your model.
Okay, but could you see how over time this thing sticking up like that could then get buried in another layer, and it would
Sure.
look like it transcended two boundaries or a boundary?
Yes,
Okay,
definitely. Yeah.
all right. All right, so maybe we can move away from the slideshow for a second, because I'm going to have to kind of go off road here. So in the last 5,000 years, you think that there have been so many eruptions in this area that it's going to create all of these different layers going up. So that would be, let's say that there were 100 different layers of different things happening. So that would be one every what, 50 years, or I don't know. If you're saying 5,000 years divided by 100, that's 50, right? Every 50 years, there's a volcanic action that's doing something there.
Well, and by the way, I have an unfair friend making comments that I'm going to bring up shortly, but I'll answer this and then I'll bring up his comment. But uh, the question was how many times in order to make these layers, or it basically is the volcano erupting. And
The frequency.
yeah, well, and I would say this is probably you're assuming that the layers are from different uh volcanoes and or different eruptions, and I'm not going to assume that. I would say this might be from one eruption. I think it's more likely just one eruption, because part of the evolutionary, thinking that I think is wrong is this idea about layers forming over millions of years, or even just over periods of time. Because now I'm not saying that there can't be layers that form over periods of time, but I also see that layers can be formed immediately. Even when you put, different size rocks and sand into a jar, it'll form layers immediately. So you can get layers without any time or separate events happening. And when you have a volcano eruption, you know, you may have one eruption, but weeks in between certain things happening, right? So, they can continue, be erupting over a period of time that, wouldn't require multiple eruptions at separate time periods in order to form those layers.
Okay. So
Okay,
far, you're
so
kind of throwing me for a loop because you're basically just you basically just condensed huge periods of history down into 5,000 years, saying, okay, it happened the way certain evidence seems to point. It just happened very fast. So I appreciate that argument. And okay, so let's go to your unfair friend, please.
okay, cool. Yeah, actually, Hillary's emails, I didn't know. I didn't know you were a young Earth sympathizer. I'd be really interested to have a talk with you about this because you just surprise me all the time. And he may not be a young Earth. I don't know what his beliefs are about this, but he actually surprised me. He says maybe radioisotopes can help. And then he brings up the organic layer, meaning carboniferous. Now, the reason that he's bringing that up is think about the talk that we had last week on carbon 14. And remember at the end, and you asked me, why did you bring that up at the end? And I wasn't sure what you meant. But the reason I actually did bring it up is because on my slide, it says they found carbon 14 in fossilized wood. In other words, in petrified wood. So even petrified wood has carbon 14 in it. Now, these specific petrified trees at this specific ridge, I don't know if they've been tested, likely not, I don't know. But, we do find carbon 14, which if these are millions of years old, then, petrified trees should not still have carbon 14, and yet we find them. So I think that's a good sign that these are within the thousands, not millions of years old.
Okay. All right. Well, thank you, unfair friend. Talking about radioisotopes, let's go ahead and go to the next slide then, and we'll talk a little bit about what old Earth scientists say about this area. Okay. So there, you have Yellowstone National Park, which has a super caldera, but these particular formations are actually predate that, and there's something called the Absaroka volcanic supergroup, and there's three different volcanic kind of periods. Well, actually, kind of subgroups, I guess you would say, and they are the Washburn group, which is the oldest one, the Sunlight group, and then the Thoroughfare Creek group. And I kind of did a color code so you can kind of see, the Washburn group has basically been overlaid mostly by the Sunlight group, and then the Thoroughfare Creek group after that. So perhaps Rebekah would say all of this is happening in 5,000 years and these entire mountains broke down in that time. I don't know. But let's go ahead and go on to the next slide. And so, we were talking about radioisotopes. There's basically three ways that they're dating the volcanic materials of this. One is called, I think, a lithographic unit. And I assume that that's talking about how the different levels of these volcanic materials are interplaying with each other. So again, what you see is that the Washburn group gets overlaid with the Sunlight group. And at the edges, there can be kind of non-conforming features, like sometimes they're contemporaneous and they overlay each other, but ultimately one covers over the other one. And then you have other, features like these alluvial features of the specimen ridge, that could be from erosion of water and carrying materials down somewhere, or lahars that kind of like Mount St. Helens kind of, blow away a huge portion of the mountain and, spread out kind of like a vast mud, stream of goo. But we talked about radioisotopes. So one of the ways, the second way I'll mention that they date this is by what's called potassium argon radio dating. And I thought this was just ingenious when I read about it. So potassium argon radio dating, potassium can decay into two different elements. One of them isn't very useful because it sticks around, but argon is radioactive argon. Uh, Sticks around only if the rock is solidified. So then it kind of gets trapped as a bubble inside of the rock. So while the lava or magma, if it's underground, I guess, while the rock is liquid, the argon can escape and diffuse, through the rest of the material. But if it's a solidified rock, it can no longer do that. And so this becomes a way in which scientists can gauge how long this particular piece of rock has been in a solid form. And so they've done radio dating of these different areas and the different layers. And so they've come up with, different ages for these rocks. And so is there any comment on that, Rebekah?
Oh, yeah, I got a lot to say about that. But I would like to put up, you have an unfair friend here. And I happen to know that this man is a geologist, and
Okay.
I think he has a PhD in geology, if I remember correctly. And he worked in oil for a long time. So this is Howard. And he says the C14, I know we're interrupting. We're kind of going back to the previous topic. I will get to the potassium argon, but I just didn't want to
Well,
let it
welcome,
go.
Howard. It's great to have a geologist here. Believe me, because this is a lot of material I have to learn. So thank you so much.
Yeah, I mean, we've had some big hitters come by here, I'm so happy when Dr. Joel comes by and Howard comes by. And so, okay, he says the carbon-14 claim is not confirmed. It is tough to follow, but there is no device that can measure no carbon-14. There is always a positive result, but it is just noise. Now, it is just noise. That is an assumption. And my claim is that the reason there's always a positive result is because the earth is young. That's why we can't find anything that doesn't have carbon-14 in it. And this this machine that they are using is so fine. I mean, we're talking, it's counting atoms. It is counting numbers of atoms. Okay. And now, wait, I want to say something.
Go ahead.
When they do the machine without the carbon, okay, so let's they have a little holder, and then they put the sample in, and then they run it. But they can run the machine with nothing in it. Okay. And it gets down, it barely can gets any carbon. Then they put in a sample, and that's not supposed to have any carbon-14 in it, and boom, you get carbon-14. So it does not make sense.
A boom in the air. Yeah. So Howard, we had a long conversation about this in our last session. So I don't want to go too far into this, but I will make a rebuttal, which is to say that I thought that if you have a huge a curve that's declining exponentially, it has a long tail, and so there's always going to be a little bit, and there also might be processes that we don't know about, breakdown of other radioactive isotopes or whatever, that may generate some tiny minuscule amount of carbon-14, but that it's like you're using one tool of science in the wrong place. So I don't have any problem with there being tiny trace amounts of carbon-14 in rock samples that long.
Well, we're not talking about tiny trace amounts. Okay. But we can go on and we can talk about the potassium argon dating. Now, and I'll tell you, I don't have the details on this right now, but people can look it up and see if what I'm saying is the truth. I did read a paper about potassium argon dating where the scientists say, look, we realize this is no good if it's done underwater, because they're somewhere off the coast of Hawaii. It may even be your little seamount, but I don't know. I don't know. Okay, it was like a volcano on Hawaii, but basically they knew that the rocks that they were testing were within the last 200 years, but those rocks were giving a potassium argon date of 50 million years. Okay. The other thing to know about potassium argon dating is that we have other dating methods as well, like uranium lead dating. And when you date a rock with uranium lead and when you date a rock with potassium argon, they give different dates by millions of years. Okay. So if we can't trust it, when we know the rock, we know the age of the rock. We know the age of the rock is less than 200 years because we have an idea about when that volcano erupted. And so we should be getting a zero result on that, but we're getting 50 million years. Okay. How can we trust this dating method for the situation that you're saying? How do we know that we're not in another situation where the potassium argon dating is way off?
Okay. Well, so I think this is a good point. I don't know. I'm not an expert on potassium argon dating or uranium lead testing or any of that, any of these radioactive. I'm not even an expert on carbon-14 dating. But I think that even if you said, okay, it has a large error bar, or you have to calibrate it based on the rock type or something like that, and make sure you get that right, it is one piece of evidence that fits into a puzzle. And so we're both trying to construct a picture from pieces of a puzzle. And so I would say radioactive dating is one piece, but you didn't address the fact that there seems to be all these volcanic layers that have occurred from mountains that actually if they're there still, they're very, very small. They've basically been eroded away, these volcanoes, or displaced or destroyed or whatever by super volcano. So you have these gigantic volcanoes that were spitting out all this magma and everything, or lava, and they're essentially gone. And that happened in 5,000 years as well. What about all these interlaying fingers of of lava and everything that they're seeing, all these different layers? That happened in 5,000 years?
Is there a reason that you couldn't have, like, I mean, I was fine with the multiple volcanoes that you suggested. I have no problem with that. Can't multiple volcanoes erupt within 100 years or 200 years and produce the effect that you're talking about?
Well, I didn't think we were going to go this way, but I could have probably figured out how much lava actually spewed out, and then with erosion and stuff, it might be difficult to calculate, but it's a huge amount. These three volcanoes have spit out more magma, I think, than even the Yellowstone super volcano or whatever over time. So there's another piece of information, and that is that most of the magma and everything spit out from these volcanoes, um, they're the magnetite or whatever it is, the iron filings, tiny microscopic iron filings and things, all point in the same direction. But there are two layers where it shifted briefly over time, the magnetic direction, and then came back. And as far as I know, in the last 5,000 years, although the poles have been shifting, they always shift a little bit, and weakening slightly or whatever. They have not reversed, right? And within the course of human history, I don't think that we have any evidence that the magnetic poles ever went from north to south and south to north back again. So I think that young Earth creationists say, hey, that happened during the flood, because they do see on the the basement level of the oceans that these iron filings, tiny microscopic iron filings, flip back and forth periodically. So how do you explain the magnetic pole changing briefly?
Yeah, and let's make this brief because that's an entirely different topic that we should talk about. But I do explain it by pole reversals during the flood. And of course, we haven't been recording these, pole fluctuations for very long, right? So this could easily fit within the young Earth timeline. And so the assumption that these have happened, and I think they say the last one was like 200,000 years ago in the evolutionary timeline, right? But this is again all based on the whole picture, the whole construct of the millions of years. So I don't think we have a scientific reason for believing that those pole reversals that we see in the rocks actually happened that long ago.
Okay, I've got another one. So two of these volcanoes, so these volcanoes, they happened in succession. There was some overlap when they were both active. But the first and the third one, okay, the Washburn and the Thoroughfare have different types of rock, right, than the middle one. Now, if they were all exploding at the same time and they were all feeding off of the same magma, and the one, keep in mind, the one in the middle is in the middle. How would the type of magma change that they're spitting out?
Well, can you tell me how you would know that they would be having the same type of magma? Are they directly connected underneath the ground?
Well, I don't know that. Yeah, but it does seem to me to be that it would be if they were all exploding in the last 5,000 years right next to each other or in the same tiny area of all within Yellowstone National Park or a little bit, it cuts the corner and so it's a little bit outside on two sides. Um, if they were all happening in the same area, and also keep in mind this other super cold era had to move in the next door, right? In 5,000 years, it seems like the magma would be the same, wouldn't it?
I mean, that just sounds like an assumption, right? It doesn't sound like we don't have any actual scientific data on that, right? So, I mean,
Well, we
my
we
my
might.
guess is as
We
good as
might. I
yours.
haven't. I haven't looked into it. I can't. I
Right.
can't.
And
I can't figure
neither
out
have
every
I.
argument you're going to make. But doesn't it logically it seem like it would be the same?
No.
Okay.
Why? I mean, you got one hole in the ground over here, you got one hole in the ground over here. The magma may be coming from a completely different source at a completely different level. So, I mean, I don't know why. And
Okay.
yeah. Okay. So, anything else?
Well, I mean, yeah, I think you kind of throw me for a loop. I would almost say you win this one. Maybe because I didn't anticipate that you would use all of the same old arguments, but just say, okay, it happened within 5,000 years. It seems awfully fast to me, but
Well, I think that's because you're used to thinking in terms of millions of years. And so it seems awfully fast, but thousands of years is quite a long time. It's plenty of time for volcanoes. And so, you know, I don't see why I don't see any scientific reason to believe. And Howard's here, so maybe Howard can give us a scientific reason to believe that this, had to have happened at the long time scale. But yeah, otherwise, I think, yeah, I mean, cool. Well, thanks for saying I won this one. Okay, well, maybe we're just having a so okay. Howard did put up a comment. He said it's not enough time for the thick lava flows to cool to their current temperature.
thank you, Howard.
Now, I mean that, I would like some specifics on that because, I mean, I've even personally touched a lava rock after it cooled, I mean, how long does it really take lava to cool? And maybe maybe when it's layered, it takes a little longer. But I mean, I watched a lava flow and then took a stick and stuck my stick into the lava, pulled out the lava, watched it form a rock, and then I
But
was able to pick up the rock a little bit later.
but we're talking about mountains here, Rebecca.
Right. Yeah.
Mountains of magma.
Well, but I mean, we're watching lava flows happen in Hawaii and other places, right? And so there's big formations happening, and those are cooling off. So I don't, and within our lifetime, right? So why why does it take millions of years? Like, why isn't 100 years enough? Why isn't 200 years enough? Why isn't 1,000 years enough?
Well, why didn't the center of the Earth harden already? It's thousands of years.
Well, that's a good
Because it's
question, but we don't
insulated.
really know that much about the center of the earth. So, okay, but I think now we're just getting into speculation,
Well,
right? You don't
you're
have
to
data.
me, it's all speculation with you because you're like, oh, it's 5,000 years. That it just it seems to contradict the facts. I mean, when we were doing the seamount, the amount of material that the hotspot in Hawaii threw up could literally put 1 kilometer of material over the entire state of California. And you're saying, oh, it just happened, during the flood. It's like, so it's hard to know what numbers to come up with, but I think if you came up with the numbers that these three this super volcanic formation generated, over millions of years, if it spit out all at once, it probably would have made the entire atmosphere of the Earth unbreathable. I mean, it just, like it did, because it's not just these volcanoes, right? If you're saying every alluvial deposit of volcanic material happened within 5,000 years around the entire planet, you're saying that all that happened in 5,000 years. How can we even breathe? Wouldn't the atmosphere just be smelling of rotten eggs right now? I mean, it. So I think there's problems with your logic, but it's just hard to know what exact fact to come up with to combat your answers, because it's just like, oh, okay, well, it's all just compressed. You know what I mean?
Yeah, well, I'm not sure why. Like, I have definitely not calculated the amount of, ash or whatever would be in the atmosphere causing a problem. I haven't calculated that. So that would be kind of something interesting to look into. And
Another problem is we didn't have nuclear winters. There were just one volcanic eruption. What was it in the 1800s or whatever, caused 3 years of cool winters, that or cool summers that caused crops to fail. So if we had all this activity going on for the last 5,000 years in Utah, even that alone, how could anything survive? You know what I mean? I don't. It doesn't make sense to me that would be 5,000 years.
okay, well, maybe we can do a further investigation into this one and find out, are volcanoes, volcanic eruptions to the degree that we see of the flows really a problem for Earth's atmosphere in this time period? So that would be something good to look into. We have a couple more comments, and then I can introduce my thing for next week. So Hillary's emails says gravity and compression prevent the magma and cores from cooling, in regard to your thing about the Earth's core. And so so Howard says conductive cooling is easy to calculate. Cooling rates are easy to calculate. Well, if that is true, I would love to see the calculations and find out if it is. I do not do math. If somebody sends me math, I will trust your math, because I don't want to. I just have zero interest in math. So math is something. If you send me a little equation and you say this shows the rate, I'll just believe you. Okay. But because somebody else who knows math can easily check that and say if you're wrong. But I will just trust your math. But if that's true, let's do it. Let's do some calculations on, are these lava flows a problem for the time scale that I'm mentioning? And finally, Hillary's email said, yeah, the volcanoes probably mostly went off close together in time and early. Awesome. Thank you. Okay, guys. Well, for next week, I'm going to introduce the challenge that I'm going to be giving to Nathan. And I really like choosing things for which there is no evolutionary explanation. And I think this is one of those things. There are some possible responses, which I will definitely address, but I don't think there's any good responses to this. And so this, oh, whoops, I'm sorry, I have to remove yours. But so the challenge for next week, Nathan, is soft tissue found in dinosaurs. Now, this was found late 90s, early 2000s, and basically when it was first discovered by Mary Schweitzer, and by the way, this is blood vessels and collagen from dinosaur bones that were this was actually an accidental discovery because nobody was trying to find this in dinosaur bones because this should be long gone. And at the time when Mary Schweitzer found this, and she's not a young earth creationist, she's an evolution believing Christian, but she found this accidentally because she left the bones in some kind of solution too long. And when she came back, the bone was gone. This was there. Now, she repeated this over and over again. Why? Because the community, the scientific community said that has to be contamination. Somebody ate a turkey sandwich over the dinosaur bones. Somebody ate a turkey sandwich while hovering over the dinosaur bone, and that's what this is. The scientific community completely rejected this. Okay, they said it has to be contamination. Why did they say that? Because blood vessels decay and collagen decays. These are not things that stay for millions of years. Okay, so the normal half-life of the peptide bonds that hold proteins together, including collagen, is about 500 years under normal conditions. Studies show, both secular and the young earth creationist one that I sent you, that I was hoping you'd watch before this so you'd actually already have a heads up, shows that the maximum possible age, that any bit, like any piece of collagen, any percentage at all, 1%, the max it could survive is 500,000 years. So this is another thing that rules out millions of years. This has been repeated so many times now, and I'm focusing on the dinosaurs just to narrow it down. But after this finding, now the studies have been repeated over and over again, not just with dinosaur bones, but with fossils at every layer of the fossil record, up to 400 million years old. So this and beyond. So every layer of the fossil record that we have tested, we have found soft tissue remaining in the fossils. Now I'm focusing
Park,
on the,
here we come.
What?
Jurassic Park, here we come.
We could be on the way to that. Okay. So because we could actually find a dinosaur if the earth is only 6,000 to 10,000 years old. It's possible to find dinosaur DNA. And so right now this has been, but I'm focusing on the stuff in dinosaurs because that's enough right there. In all of these dinosaurs, there has been collagen found. In all of these dinosaurs, there has been blood vessels and structures resembling red blood cells. Okay, found. So the scientific community did not accept this finding for quite a long time. but now they've accepted it. But we'll talk about it. We could talk about it all next week because that'll be the topic next week. But anyway, thanks everybody for watching. Do you have any final thoughts, Nathan?
Well, great job. You kind of threw me for a loop. But hopefully, thank you, Howard, unfair friend. Kind of pulled it back, gave me some time to think it through and decide, yeah, having volcanoes going off every few years, massive volcanoes going off, probably not conducive for life on Earth. So.
Well, I'm not sure about that. I actually don't think it's a problem, but we can look more into that. Who knows? Maybe I'll bring that to you as a challenge later when I find out otherwise. So, anyway, thanks everybody for watching, and we'll see you next week.